Assalamualaikum dear viewers, hope you are doing well. I am Shoaib Dayo again here with another topic of electrical engineering. You want measure the voltage through the voltmeter or current through the ammeter. So today we are going to perform the experiment by measuring the voltage and the current using Multisim software. So ammeters in electrical engineering or in electrical circuits are used to detect the amount of the current, either it is AC or the DC, and they are always connected in series with the circuit. And the voltmeters are used to measure the amount of the voltage in the electrical circuit, and always they are connected in parallel with the electrical circuits. So let's do the simulation by measuring the voltage and the current in the electrical circuits. So dear viewers, this is the Multisim software you can see on the laptop screen. So here we can simulate the different types of the electrical circuit in this software, and this is the toolbar in the Multisim, and this is the place source where you find out the different power sources, the signal voltage source, signal current sources, the current voltage, control voltage, current, okay, all these functions, and also the basics in which you can find out the relay, sockets, resistor, capacitor, inductors, different electrical components, okay, transistors, and everything is available, okay. So now our task is to measure the voltage and the current in the electrical circuit. So first of all, see this electrical circuit. So this is a simple series circuit in which 3 resistors are connected in series across this voltage source, which is the VDC 20 volts. Now we have to calculate or measure the amount of the current with the help of this ammeter, and also measure the voltage across the each resistor, because in the series circuit the current throughout the circuit is the same one and the voltage across individual resistor is different. So the DC series circuit can be defined as the DC series circuit in which the resistances are connected end to end, so that there is only a one path for the current to flow. So that is called as the DC series circuit. So we have a 3 resistor in this circuit. So R1 50 ohm, R2 100 ohm, and R3 150 ohm. So what is our task? We have to we have to measure the amount of the current by connecting the ammeter in series. The total current it will be detected with the help of the ammeter, and the voltage we have to measure across the each resistor with the help of the voltmeter. So first of all we need to simulate draw this circuit on the Multisim software and verify the results through the software of the verify the results of the current and the voltage. So first of all we need to take the DC voltage source. So by clicking on the place source, power source, and take the DC power. So this is the DC power, and also go to the basic and take any resistor, okay. So this is the resistor number 1, resistor number 2, and resistor number 3, okay. So these are the 3 resistances, okay. So connect these end to end of the each resistor. So this is connected with the negative of the supply voltage. Now first value of the resistance was 50, okay, second is 100, third is 150. So now connect the ground to the circuit, then the path of the circuit will be closed. by connecting the ground. Okay. So ground is connected. Now this is the series circuit. Okay. Now we have to measure the current which is flowing through the series circuit. So always ammeter is connected in series with the circuit. So it will give us the total amount of the current. So the total equivalent resistance of this series circuit is that by adding these three resistances, the total equivalent resistance will be the 150 and 100, and this will be the 300 ohm, which is the RT, total resistance of the circuit. So first of all we need to break this circuit. By breaking it, so connect the DC voltmeter, because this is the DC circuit. So click on the place indicator, so where you can find out the ammeter. This one is the ammeter horizontal we are taking. So this is the ammeter, digital ammeter. So it is connected in series with this circuit. Now this will give us the reading of the total current flowing through this series circuit. Now if you find out the voltage across the each resistor, so you need to connect the voltmeter in parallel across the each resistor, so where you can easily find out the voltage across each and individual resistor. So how? So click on again place indicator where you have voltmeter. So voltmeter, here you can find out this horizontal. Okay. So first voltmeter is connected across this R1. Okay. Always it is connected in parallel. Okay. This is the voltmeter connected in parallel across the resistor 1. Second voltmeter again we have to take. So this is the second voltmeter, again it is connected in parallel across the R2 resistor. Okay. And again we have to take the third voltmeter, which is connected in parallel across the R3 resistor. So this is the R3 resistor. Now this is the button to run the simulation. To resume the simulation, the circuit will work. Now let us see. Now this is the current, which is the 0.04 ampere current is flowing through the circuit, because this is the series circuit. So obviously resistances are connected end to end, so there is only a one path for the current flowing. So obviously so current is the total current of the circuit is the 0.04 ampere, and the voltage across the R1 is the 2 volt. The voltage across the 100 ohm resistor is the 4 volts, and voltage across the 150 ohm, which is the 6 volt. So by adding this, so you will get the same again total voltage applied to that particular circuit. For example, 6 and plus 4 10, and 10 plus 2 is equal to 12. So these are the results that can be easily verified through the Multisim software, that the total current is measured by this ammeter, which is connected in series with this DC series circuit, and each and individual voltmeter is connected across the each and individual resistor to give us the voltage reading across each and individual resistor. So this is the simulation which is to be done on the Multisim software. So we can also verify these results through the mathematical formulas by applying the Ohm's law, which is the I is equal to V over R. See this calculation. So here the total current is 0.04 ampere. So let us validate also this result through the formula. So now this is the circuit, okay, and you can see R1 is the 50 ohm, R2 is 100 ohm, and R3 is 150 ohm. Okay. Now so total equivalent resistance of this circuit is by adding these three resistances. So 50 plus 100 plus 150 is equal to 300 ohm. Okay. Now I total, so I total according to Ohm's law, I is equal to V over R. So apply the total DC voltage, which is the 20 volt, divided by the total resistance of the circuit is 300 ohm. Okay. So you can easily So here in this circuit we are applying the 20 volts. So here we are getting the current value is the 0.0066 ampere. So change the value of the voltage over here 20. So verify this result. So this is the 0.067, almost 0.066 or 67 ampere current flowing through this circuit by when you are applying the 20 voltage DC. So if we have a voltage in this circuit is the 20, so obviously so we are getting the same current which we have already get through our simulation. So 0.006 or 0.066 or 0.067 ampere is current flowing through this circuit. And also we can easily find out the voltage across the each resistor. For example, here the 50 ohm, if you are applying the 20 volts, so we are getting the 3.33. So by applying the Ohm's law, it is the V is equal to IR. So I is this total current, which if is multiplied with this this R1, so this will be give us the reading of the voltage V1. And here we can also measure this calculate this voltage through the mathematical formula according to Ohm's law, V is equal to IR. So V2 you can easily find out here by multiplication of the total current with the R2, and also you can easily find out this voltage V3 by applying Ohm's law by multiplication of the IT total current multiplied with this R3 resistor. So you will find out the same result, or you will get the same result. So this was the simulation of the DC series circuit, in which we have measured the amount of the total current through the ammeter and the total voltage the voltage across the each and individual resistor by connecting the voltmeter in parallel across the each resistor. Let us do the simulation of another electrical circuit. Now here this is the parallel circuit. So the parallel circuit is that in which the number of the resistances are connected in parallel across this voltage source. So this can be called as the parallel circuit. And also the one end of each resistance, you can see the one end of each resistance is joined to a common point, and other end of the each resistance is joined to another common point. So there are so many paths for the current flow as the number of the resistances, so that is called as the parallel circuit. So here if we are placing the ammeter over here, so this will give us the total current which is to be flowing through the circuit, and in the parallel circuit the current is divided as the number of the several paths. Here there are the 3 paths, so 3 ammeter if we are placing, so this will give us the individual value of the current in the each path. From this ammeter will give us the current flowing through R1 branch. This ammeter will give us the reading of the current which is to be flowing through R2 branch, and if we are placing the ammeter over here, so this will give us the reading of the current flowing through the R3 branch, and if we are placing the current over here, so this will give us the I total current which is to be flowing through the total circuit parallel. So let us do this simulation and draw this diagram on the Multisim software to observe the result of the voltage and the current. And in the parallel circuit, if we are placing the voltmeter over here, or if here, so in the parallel circuit the voltage is the same one, but current is divided as the number of the paths are mentioned. Okay. So again go to the place source. So take the DC power, okay, and take again the resistor through this basics resistor, take any value and we will change it. Third, 3 resistors we have, and now we have to connect these resistor in parallel. Okay. So now the first resistor is of the 50 ohm, second resistor is of 100 ohm, and third resistor is of 150 ohm. So connect the supply voltage, okay. Now connect all these resistors in parallel. Okay, and now this one. So take the ground, so this is the ground we are going to connect. So I have taken multiple grounds. Okay. Now this is the circuit. Now we have to select the set the voltage 20 volts. Now if you find out the total current of this circuit, so by connecting, break this circuit, break this path, connect the DC volt say ammeter, sorry, in series with this path. So this will give us the reading of the total current flow through this circuit, and obviously this is the parallel circuit. So if you find out the current across this R1, R2 and R3 resistor, so by placing the individual ammeter in series, so this will give us the reading of this current. Okay, and this is the second ammeter. This will give us the reading of current flowing through the R2 branch, and if you want to measure the current at the R3 branch, so this ammeter will give us the reading of the current through R3 branch. So simulate this circuit. Now you can see this is the total current. Okay, this total current by easily you can find out by connecting or by measuring. You can easily measure by detected through the ammeter which we have connected in series across this whole circuit, and this is the 0.4 ampere current flowing through this R1 resistor, 0.2 ampere flowing through the R2 resistor, and this is the 0.133 ampere current flowing through the R3 150 ohm resistor. So if we are going to connect the voltmeter by measuring the voltage across each resistor, so take the voltmeter from this place indicator. If we are taking the voltmeter vertical, so easily we will check this value. So here this voltmeter will give us the reading of the voltage across the R2 resistor. Okay, and this voltmeter will give us the voltage across R2 100 ohm resistor, and third voltmeter reading, this voltmeter reading will give us the voltage across R3 resistor. So see this. So as you can see, the voltage across each resistor in parallel circuit is the same one. So the voltage throughout the circuit in the parallel, when the circuit is the parallel circuit, so the voltage is the same one. As you can see, we are applying the 20 volts. So at each and individual resistor, by connecting the voltmeter in parallel, you are getting the, again you are observing again the 20 volts, the flowing voltage across the each resistor, and the current is divided. As you can see, there are 3 paths. So obviously the current is also divided into the 3 paths, and that can be easily detected with the help of these 3 ammeters which are connected in series with the each and individual branch. So this is the simulation of the parallel circuit, in which we have taken observing the readings of the currents, total current, and also the current through the individual branches of the resistor 1, 2 and the 3, and also we have observed the voltage across the each resistor, and also we can observe these results with the help of the calculation. So here the current which we are getting here, the total, which is the 0.733 ampere, if we are applying the 20 volts to this circuit, and also the R1 current is the 0.4 ampere. So you can also done these calculation calculation with the help of the formulas. So you can see this is the again R1 50 ohm, R2 100 ohm and R3 150 ohm. You can see there are the 3 resistors are connected in parallel across this VDC. So if you find out the total resistance by, if there are the 2 resistance are connected in shunt, so a product over some formula that we have applied, and we are getting here the total resistance, which is the 27.27 ohm. So VDC that we have already applied. So this one I total we have to find out. So this will be VDC divided by RT. So RT of this total circuit is that total equivalent resistance of this circuit is that 27.27 that we have get through this formulas, and by dividing the voltage and also the resistance, so we are getting here again the 0.733 ampere, which is the total current. Also we have observed this current here, which is the total current in the circuit, and also the R1 we can also find out the current through this R1 branch. So by applying simply Ohm's law, I is equal to V over R. So if we have a voltage we are given to this circuit, which is the 20 volts, which is the same one. So by I is equal to V over R. So V 20 divided by this 50, so we will get the 0.4 ampere. And if you want to measure the current through the formula, so calculate the current through the formula. So this again voltage is 20, so I is equal to V over R. So here 20 divided by 100, you will get that 0.2 ampere. And again, if you find out the current or calculate the current in this branch R3, so again the voltage is the same one, 20, so I is equal to V over R. So this is the 20 divided by 150, and you will get the 0.133 ampere current. So this was the parallel circuit in which we have done this simulation through using Multisim software, and also we have validate or observe the result through the mathematical calculations and also on this software. So dear viewers, this was the experiment regarding the measuring of voltage and the current and different electrical circuits that we have done through our Multisim software, and in which also we have validate our result through the mathematical formulas and also through the software. And I hope that you have understand the today's experiment, and at the last do subscribe my YouTube channel Shoaib Dayo for more informative videos related to the electrical engineering area. Thank you.